In today's video, we're going to look at the tests we can do to check if a solution contains anions, which are just negatively charged ions. So we'll cover the tests for the carbonate ion, the sulfate ion, and the halide ions. Let's start with a test for carbonates. This test relies on the fact that if a carbonate reacts with an acid, it will form a salt, carbon dioxide gas, and water. This by itself isn't very helpful, but there is a very easy test for carbon dioxide, which is that if we bubble carbon dioxide gas through a solution of lime water, it will turn that lime water cloudy. So to test for carbonates, all we do is add some dilute hydrochloric acid to our test sample, and then take any gas that's produced and run it through some lime water. Because if carbonates were present in the original sample, then carbon dioxide will have been produced, and so it will turn the lime water cloudy. Or in other words, if the lime water goes cloudy, then that's a positive test result, and it means that carbonates were present. Next up, we have the test for sulfates, which also has two steps. The idea behind this test is that if we add barium ions to our test sample, then they'll react with any sulfate ions present to form barium sulfate, which importantly is a white precipitate. So if we see a white precipitate forming, then we call that a positive result, and it tells us that sulfates are present in our sample. Now that's the theory behind the test, but let's now look at the two steps themselves. Before we can add the barium ions, we need to add some dilute hydrochloric acid, which will remove any carbonate or sulfite ions in our sample. The reason we do this is because these ions are basically impurities, and could also react with our barium ions to give us a white precipitate, which would confuse our results. Once we've done this and got rid of those impurities, then we can add the barium chloride solution, which is the important one that contains our barium ions. And so at this point, if any sulfate ions are present, we'll see the white precipitate form, and that will be our positive test result. The last test we need to look at is the one for halide ions. So chloride ions, bromide ions, and iodide ions. The halide test is pretty similar to the one for sulfates. But for the first step, instead of adding dilute hydrochloric acid, we add dilute nitric acid to get rid of all of those carbonate and sulfite impurities. And for the second stage, instead of adding barium chloride, we have to add silver nitrate. The key idea this time is that the silver ions from the silver nitrate can react with the halide ions to form a precipitate. And importantly, the color of the precipitate depends on the particular halide that the silver ions react with. So if it reacts with a chloride ion, it will form silver chloride, which is a white precipitate. If it reacts with a bromide ion, it will form a silver bromide, which is a cream precipitate. And if it reacts with an iodide ion, it will form a silver iodide, which is a yellow precipitate. So by doing this test, which we sometimes call the silver nitrate test, and seeing which color the solution turns, we can see which of our halide ions must have been present. Anyway, that's everything for this video. So if you found it useful, then please do give us a like and subscribe, and hopefully we'll see you again soon.